Worldwide, there are about 200 million patients that are affected by age-related macular degeneration. And the problem that we're facing now is that by 2040, this is expected to rise to 300 million. So we're at a critical stage now where we need to understand more about age-related macular degeneration to prevent this sight loss that's going to happen in patients. My main area of research is the retinal pigment epithelium, and these are cells right at the back of the eye which are critical to vision. So they don't detect light themselves, but what they do is they look after the cells that are detecting light. So if the RP isn't working properly and it's not doing its job properly, this affects the photoreceptor cells, and in turn this affects sight. Mitochondria are the battery of our cells. They produce all the energy that a cell needs to be able to survive and to do the job that it's meant to do. So the RPE need a lot of energy to keep those photoreceptors healthy, and they need a lot of energy to do the job that they're supposed to be doing. The Seahorse Analyzer will really help us to understand more about diseases like age-related macular degeneration and glaucoma. So we can take cells from patients and we can grow those cells in a dish and understand for the first time what's actually happening in a patient's cells in terms of their metabolic activity, whether they're making enough energy for themselves to survive and to keep the other cells in the retina healthy.
As a researcher, it's really exciting to have access to the Seahorse Analyzer. Essentially, it allows us to do really high throughput investigations from samples from lots and lots of patients. And that's really important in the context of conditions such as glaucoma and macular degeneration, because it allows us to see essentially what are the aspects of the disease that make patients different. And again, the reason why that's important is it will allow us to hopefully unpick some of the mechanisms of disease and some of the things that make those diseases more severe in some patients and more mild in others, and hopefully allowing us to tailor our treatments to those patients in the future.
So this gives us a whole new way of looking at mitochondria. It gives us a new way of looking at how mitochondria are affected by disease, and it also gives us a new way to see how we can change mitochondrial activity to affect the cells. And this in the future could lead to potentially new drugs that we can target to mitochondria being used in patients. My message to supporters of the charity is that, your donations and your interest in Moorfields Eye Charity is really helping to push forward research here at the Institute of Ophthalmology. And I'd really like to thank every single person for donating to Moorfields Eye Charity. Without your help, we wouldn't have been able to purchase this equipment and take forward our research into vision loss.